Okay, seems that we are live. So welcome to this new session of Coffee Break with Eddyfi. My name is Frédéric Reverdy, and I will be your host today. So I hope you have your mug and your coffee. So today we're going to talk about TKY Weld Inspection using Capture, so the software for the Gecko and the Mantis. As usual, few reminders. There is about a 10-second delay between me talking and you actually seeing it, so that's why I will be answering the question at the end. If you want to ask questions on the chat, you need to have a Gmail or a YouTube account. This video will also be recorded, so you can also after go to our YouTube channel and ask questions there. And see all the other videos by my colleagues as well. Okay, so let's jump in. As I mentioned, today we're going to talk about Tky Joint. Here is my email address in case you want to send me an email regarding this or other things. So Tky joint. So usually this is referred to a joining process that's going to join two pieces of metal, either at 90 degrees like on this picture or with an angle, and we'll see the two examples today. Typically this is being joined by using fillet welds, but you can think of other joining processes like friction stir welding, for example. And you have a big variety of shape. You can have a plain T, meaning without a preparation. So we'll have one example of that. You can also have a single bevel, double bevel, or other type of preparation. So if you look at the international standards, ISO, ASME, and others, they provide guidelines on how to inspect this type of welds with conventional UT or phased array. Today we will be focusing mainly on phased array. So ideally, to inspect a T joint, so here's the T, here is the base plate. The best location is actually on the plate opposite the web, so here. Because you have a direct access to the two welds when you have to, and you can just do a regular linear scan, or if you do conventional, you can just use a regular L0 probe to inspect this fusion face right here. You can compare that with two sectoral scans to actually be normal to the other fusion face when you have a prep. Sometimes you don't have access to that surface, so alternative approaches, you can basically put the probe on the website of the flange surface, and you can perform a sectoral scan and or a linear scan. Of course, you have to do a scan plan, and you have to show that you are doing a full coverage of the weld or welds when you have to, and as much as possible that you are normal to the bevels. You can also inspect from the T, and that's the same. You have to do a scan plan to show that you are covering your weld. So here with the high angles, you can inspect this bevel, and with the low angle after rebound, you can inspect this bevel with either a sectoral scan or linear scan. So for my demo today, I will be using two blocks. One is a T, or what's left of it, with a very thick base plate of 40 millimeter and a T of 12.5 millimeter. There is no prep, so there is no fusion between the T and the base plate. It has two fillet welds. And actually, on that sample, it has some fatigue cracks right here, and that's why they actually cut it. My second sample that I will be using is a wide joint that was made by our friends from Sun Inspection. We asked them to do and to put three defects. So there is a toe crack right here, a laminar tear, or an incomplete wood penetration. Okay, so now let's go into the demo. So here I'm sharing my webcam, and you can see here the sample that I will be using first. And here I'm connected to my Gecko through Wi-Fi, and you can see the screen of my Gecko right here. So the first example we're going to do is the T section, the one I was showing at the beginning. So, and I'm going to show how to define that component in Capture. So first I imported a picture of it. You can simply import pictures by clicking here. So in Capture, so you can see here 3D of my components. So in Capture, at the moment, we can handle 4 different parts. We can obviously do plates, pipes, nozzles. Nozzles will be covered, I think, next week by my colleague Dean Mason in another coffee break, and a fillet weld. We can also import 2D CAD files as overlays. We'll talk about that in another coffee break as well. So the fillet weld actually is pretty easy to define. This is a parametric definition. You have a drawing here with all the different lengths, and you just have to input all the values. And here for the angle and thicknesses, again, the thickness of the base plate is 14 millimeter, and the thickness of the T is 12.5 millimeter. We have a 90-degree one. Then you can define the weld. So here we don't have any prep, so I'm not using any chamfers right now. I will show that later with the Y joint. So the only thing we have to define are what we call the back strip, or they're also called legs, which is basically that length and that length. So I can remove them, for example, if I have a fillet weld on only one side, or I can add them, and I'm just going to adjust the length. Okay. This is just carbon steel, so I'm just going to use carbon steel. For the probe, I'm just going to use a regular 64 element 5 MHz G3, so which is a 0.6 millimeter pitch, very typical for 5 meg. I'm going to use shear 55 wedge. You can see that it's already calibrated, but for those who haven't seen the calibration, I'm just going to do it. It's under reference, angle and height calibration. So what we are doing right now, we are firing all the elements one by one. So this is element 1, this is element 64, and what you are seeing right here is the back wall. As I move, you can see the back of my wedge. So I just have to adjust my gate right here to make sure I see all the back wall. Press measure, and you can see a white line right here. So that's a linear fit to measure the angle of the wedge and the height of the wedge. So this is the wedge delay calibration. You don't have to do anything else. Here you can see that my first element is positioned right here. It's down, but the system also checks automatically if you misposition the element. So let's say I'm going to tell him my first element is up. If I redo my calibration, you can see here that is putting back my first element at the right location. Okay. I'm going to use a wire encoder, a string encoder right here. Okay, so let's go to the delay lows now. We are going to put the probe where it's located right now, so we're going to put the probe on that surface. And here we're going to use a full 64 element, and we are going to do a sectoral scan. And I can actually adjust. Using the wheel of the screen, I can adjust. I use 1 degree. I can adjust here the coverage. So I just want to make sure I'm fully covering my weld. So the low angle after reflection, I'm going to inspect that side, and the high angle right here. For focusing, you can see the focal point right here. Focusing at 80 millimeter true depth. So 80 millimeter, which is 2 times the thickness of the base plate, because I'm looking for any defect right here. Compute the delay lows, and I have a signal live of what's happening. So I can actually adjust my delay lows if I'm not satisfied with the result. So what do we see right here? We see several echoes. We see a very strong echo right here, which is actually a geometry echo coming from the back of the weld. So actually from that weld right here, you can see it's actually round. We can see a small weak echo right here. Okay, so right here. So remember, there is no prep. So there is a weld right here. There is a fillet weld. So this is an echo we are getting at the interface, which is not welded. And on that side, we have corner echo, and you can see some tip diffractions. So we actually have one of the fatigue cracks that initiated on that mockup. So for the gates, I'm just going to do a regular gate sound path. I'm just going to acquire all the data. For the scan, I'm going to use, as I mentioned, I'm going to use my string encoder. So you see, as I move, you can see the probe moving in the 3D of the component. All right, so let's go to the acquisition. I'm going to try to do a good job. Just going to use my encoder right here, and I'm going to try to move as straight as possible. Okay. Okay. I can see I acquired 100% of my data. I didn't miss any frames. I can save the data and analyze. Just going to give a standard name. Okay. So here we have our sectoral scan, A scan, C scan. So right now we have here a D scan. We have our top view. So you can see here that echo from the weld along our scan. So this is my echo. Here this is the echo from the back of the second fillet weld. Actually here we have slide drill hole on the other side. There is one here and there is another one right here. And we also have a 3D view. We talked about it a little bit in the first coffee break that we did about the analysis tool. So that's a new tool in Capture 3.1. You can actually export all the data in a 3D view. So that's actually pretty cool because you can see the echo being superimposed with the 3D. So here this is the echo from the back of my weld. So from that one, this is my defect. Actually, I'm not very good at moving in 3D. This is my slide drill hole and so on. Okay, so a cool thing about that sample, so I'm going to try to move my webcam and hopefully it's gonna focus a little bit. I don't know if we're going to be able to do it. Okay, here you go. You can see some notches that we have on the other side. So something I'm going to do here, I'm going to try to inspect those notches from the other side. Kind of a similar inspection to the annular plate of above ground tank, sorry. I'm just going to put my probe here and I'm going to try to look for this defect after a skip to go underneath the fillet weld. So for that I'm going to change my scan plan. I'm going to put my probe against my fillet weld, so I know the value, and I'm going to extend a little bit my scan, let's say about 75 degrees. So you see here, now I can actually cover like a pretty wide range, and you can imagine I could be looking for corrosion or any defect that you would be having on the surface. Okay, I'm going to extend my range a little bit. So what we see right here, we see the echo from the back of our weld, we see the echo from the back right here of our sample, and we see here our notches. So it's interesting, like very similar again to an annular plate inspection. Obviously the base plate here is much thicker, but you can actually use the fillet weld part to calculate delay lows and go underneath the Tky joints. So I'm just going to do an inspection again. I'm going to extend my gate to make sure I acquire all the data. Okay. Again, I'm going to try to do a scan. A little bit of water. Here we go. I'm going to save the data. You can see I missed some frames here at the beginning. I kind of didn't play very well with the probe. Alright, so we see our 4 notches I showed you before on our C-scan. 1, 2, 3, 4. But it's actually interesting to look at the top view. Okay, so on the top view you can see the plate right here. And you can see the very strong echo right here. That's actually the echo coming from that side. So this is the echo coming from that side. That strong echo right here, it's coming from this fillet weld. And here you can see the 4 notches, 1, 2, 3, 4. So if we can actually also look at the 3D if we want to. So the 3D, you can see my 4 notches right here. I'm going to remove the 3D export. You can also look at a cross section right here. So for example, if I move on my 3D, you can see your defect in the 3D view, looking at the sectoral scan. I'm going to use the analysis feature I showed in the first coffee break. So this is an auto sizing feature. So I would encourage you to go back to the first coffee break or looking at the blog on our website. I'm going to use the auto sizing feature to size automatically my indication at -6 dB. Obviously I can change those values, so I'm just going to basically look around my defects. I'm just going to put one around every single defect. And you see I have quickly done an analysis. I can see my 4 indication right here in my top view, side view, and so on. And they have been added to my table of indication. So this is my 4 indication in my indication table. I'm just going to display scan start, the length, the distance to the weld center line, true depth, the height, angle, and so on. So all the information necessary for me to do to see if I'm going to reject or accept those defects. All right. Okay, so that's it for the T section. I'm going to switch to the Y joint. A little bit of logistic right here. So this is going to be the Y joint. I'm going to play Lego a little bit here. Okay. So the Y joint. Okay, so you can see here I already predefined it. My base plate and my T have 10mm thickness, and I have 70 degrees. So I have 70 degrees here between my 2 plates. And I actually have a prep here. I have a double prep. I have a bevel on either side. So that's why I actually added my chamfer, chamfer 1 and chamfer 2, with the angle and the height. So you have here the indications. So you can actually adjust when you have one bevel. Obviously, I will remove that and have a much larger angle. I'm going to keep the same probe, same scanner. Okay, and I'm going to explain a little bit something I didn't explain before. So here we're going to put the probe on that surface. I can actually do that now. Add a little bit of ladder. All right, we're going to put the probe on that surface. There is this button right here that you have access to when you are dealing with fillet welds that allow you to position your probe on any surface. So obviously the P1B will be the favored one if you have access to that surface. But here we're going to put the probe on the P2A and to look at something a little bit interesting. Regarding the delay lows, we are doing a sectoral scan, again, 55 to 85 degree. I know 85 is a little bit high, and I'm not generating this 85 degree. But I'm using a projection focusing. So projection is focusing along a line, and you can see here my line is at 20 degree. So I can change that, but 20 degree is the angle I need to put to be parallel to the base plate. I can also change my projection. Again, I'm just going to move here. So you see I can easily, with the wheel of the gecko, change where I'm focusing the energy. So as I'm using 64 elements, I'm going to focus right here and will be very sensitive to tip diffraction, if any. Here you can see, if I stop moving, okay, you can see that I have an echo right now, and that echo is aligned with the back of my plate, with the back right here. So this is just a simple backward echo from the base plate. So we see here with the overlay of the part that we actually, it's pretty easy to interpret that echo. All right, so let's go into the inspection. Again, I'm going to try to do a good job inspecting the part. Not sure. I'm going to use a envelope for the signal. Alright, so this one is actually not that easy, so I'm hoping that I'm going to do a good job. It's actually not that great. Alright, let's stop right here. Save and analyze. Okay. And I'm going to bring the drawings of the mockups to try to explain the different defects that we have. So let's look first at that defect right in the middle, right here. Well, first, let's go back to where we don't have any defects. So when we don't have any defects, we have nothing here. We just have our back wall echo coming from the back plate, the base plate, sorry. So here, this is our laminar tear that you see right here. We can see that we have a direct echo of the laminar tear. If we use two cursors, I could actually size the height of the defect. So this one is actually pretty easy. As you move, you can see, and here I disappear, I get my backward echo again. We have a very strong echo right here. So we still have our backward echo right here. So that means there is no defect here hiding my backward echo. And the defect right here seems to be outside of my part, which obviously is not possible. So I'm going to recreate my sectoral scan using the skip. So I'm folding my sectoral scan, and you can see that my defect right now is well positioned. This is my toe crack that you see right here. Remember, my probe is right here. So I have a skip right here, and I can reposition correctly my toe crack, and actually I could size as well the height of my crack right now. So that's pretty neat. And it's hard to see because it's a very small defect. So I'm going to add a little bit of soft gain right here. I have another defect right in the middle, right between my two fillet welds. And this is actually my incomplete penetration, my incomplete wood penetration. It's kind of weak, but you know, it's there. You can see that I have a second echo right here. That echo is actually also the incomplete wood penetration after a skip. So I can actually look at the same defect, and you can see it's located at the same location. And I have another one. I have another echo. So that echo right here is actually coming from two skips. So 1, 2, and 3. You can see here my echo is, everything is coming from the same location. So really being able to fold your sectoral scan many times and rebound off the different surfaces helps the operator interpret the data. So if I go back to the direct, you see that was that echo that I had at the beginning. So the 3 echoes here are actually coming from the same defect. So those were my top views and this scan. Same thing here. If I want to export in 3D, I can also export in 3D as before. Just wanna do an acquisition right now. Same acquisition, but without the overlay, just to give you an idea of what you would obtain. So I'm just gonna, if you only were able to define the plate. So I'm just using the standard plate with a 10mm one. Same sectoral scan. I'm not going to change my scan. Still going to do my 55 to 85. Focus at 10mm and 20 degree 20 degree one. Okay, so I'm going to try to do a better job this time in doing the inspection. And I'm going to do exactly the same scan. All right. Okay. So now I'm going to try to do the same analysis without the overlay. You're going to see it's a little bit more complicated. So I can see I have exactly the same scan. I have an echo right here, I have an echo right here. I can see that I have a constant echo, so I would assume that this is probably coming from my backhaul. but that echo right here would be a little bit more difficult to interpret because now I cannot skip and I cannot superimpose with the overlay of my part. Same thing here. I see, increase my soft gain again. I see I have different defects, different echoes, sorry, so potentially different defects, but it makes, without the overlay and without the possibility to skip over the different surfaces, it makes it a little bit difficult to try to interpret those echoes. So really, like the idea behind this fillet weld application is that it's to help operators define their inspection, but also speed up their interpretation. Okay, and that's it. That would be I will be ending my coffee break today. So I will now leave it to you if you have any questions regarding my presentation today. And again, if you want to ask questions, you can always go back to the YouTube channel and ask the question later. So do you have any questions? So let me go back to YouTube. Are the fillet welds included with capture, or is it an option? First question. This application is actually included with capture for all the Gecko version and the Mantis TFM16 and TFM64. So if you purchase any Gecko, you will have that application that comes with it. So no need to purchase an extra option. So you can actually buy it and play with it. So let me see. Thanks for the comments, guys. I don't see any other questions. I'm just going to give you like an extra 1 minute in case you have other questions. Oh, okay. So no more questions today. So thanks again for joining me. I will strongly suggest to go on our website. As usual, I'm just gonna do a little promo of our webpage. If you go to our webpage, you can go into the blog. To the blog, we try to put a lot of presentations about the Gecko and other techniques. All my colleagues from the other business units, you will find a lot of information right here. Also, we have this Eddyfi Academy, this is free. So if you want to go and follow some courses about the TFM or about other techniques, please go there. It's my colleagues and I spend some time to try to make it as interesting as possible. And if you have any questions, again, please send us some emails. Okay. So that will end our coffee break with Eddyfi. Next week we'll have 2 more sessions, and for the M2M side, I think my colleague Dean Mason will talk about nozzles, inspection of nozzles using capture again. Again, thanks a lot, and